Welcome to the second lecture of Polarography. In this lecture, we are going to study Polarographic cell, Polarograph, working of Polarograph and factors affecting measurement of current. Okay, let's start with our first point. Polarographic cell. Okay, the diagram shows the Polarographic cell. In this, there are three main components. First one is our indicator electrode, that is DME. It is act as a cathode. Second one is the pool of mercury, okay, which is present at the bottom of the cell, which is act as a anode, or it is also called as a reference electrode. And third component is the electrolytic solution. That electrolytic solution containing the solution of test cation plus solution of supporting electrolyte and solution of maxima suppressor, that is gelatin. So polarographic cell consists of cathode, anode and electrolytic solution. Okay, generally in polarography, DME, dropping mercury electrode, is act as a cathode. It is act as a indicator electrode. In this electrode, mercury is forced by a gravity through a fine capillary. Okay, here fine capillary is present, and through this fine capillary, mercury is flows through this fine capillary, and continuously the drops of mercury as fall into the electrolytic solution, and these drops which is coming out through the capillary are act as a cathode. Okay, the lifetime of drop is about 3 to 6 seconds, and its diameter is very small. Okay, it is about 0.5 millimeter. Lifetime is 3 to 6 seconds and diameter is 0.5 mm. The next electrode is the anode, okay, which is present at the bottom of the cell here. Pool of mercury. It is act as a reference electrode, or in some instrument, calomel electrode is also used as a reference electrode. So, a large amount of mercury which is placed at the bottom of the cell, and the electrolyte solution is placed above it. Okay, here is the electrolytic solution which is placed above the reference electrode, pool of mercury. This electrode is a non-polarizable electrode, okay, and its surface area is comparatively large as compared to the surface area of dropping mercury electrode, because the drops are very small in size, okay, and their diameter is about 0.5 mm, okay, and in comparison with this, the reference electrode has a very large surface area and it is a non-polarizable electrode. Its potential remains almost constant. Non-polarizable means what? Its potential remains almost constant. Okay, and it is act as a reference electrode. In some instrument, calomel electrode is also used as a reference electrode. Okay, and electrolytic solution containing what? It containing three species. First one is the solution of test cation. Okay, then it also containing large amount of potassium chloride, that is supporting electrolyte, and solution of gelatin is added. Okay, the next point of the lecture is the removal of oxygen from the solution. Removal of oxygen from the solution. Okay, initially the solution containing a dissolved oxygen. Before the measurement, it is necessary to expel this oxygen because the dissolved oxygen may produces some error in current measurements due to the oxidation. So, for this purpose, nitrogen gas is bubbled through the solution to expel the dissolved oxygen. Okay, the inert gas nitrogen is bubbled through the sample solution in polarographic cell. Okay, here inlet and outlet tubes are provided. Inlet tube and outlet tube. From inlet tube, nitrogen gas is bubbled through the solution, and from outlet tube, oxygen is bubbled out. So here in the polarographic cell, inert atmosphere is maintained. Then polarographic cells. Polarographic cell consists of a glass vessel. Okay, look at here. Polarographic cell consists of a glass vessel whose capacity is about 200 ml. Okay, and to that vessel there are two glass tubes, okay, side arms at different heights. Pure mercury is taken in the vessel so that it rushes into the lower glass tube, and the electrolytic solution is poured above the mercury so it is rushes into the upper glass tube. Here DME is fitted to the cell. Okay. Before the measurement, nitrogen gas is bubbled through the solution and the dissolved oxygen which is present in the solution is expelled. Here copper wire is inserted into the lower glass tube which containing a pool of mercury so that electrode is act as a anode. The next point is the polarograph. Polarograph, it is an apparatus which is useful for measurement of current during polarography. Okay, look at the diagram. It is a circuit diagram of polarograph. The circuit diagram of polarograph and the connection of the polarographic cell to the polarograph are shown in figure. Polarographic measurements require the means for varying the voltage continuously over the range from 0 to 3 volts. Okay. Therefore, here potentiometer is used. Okay. Let's see the components of polarograph. First one is the polarographic cell. You know that. Other components are battery, potentiometer, shunt, and galvanometer. Okay. Battery. Okay. Here is a battery. Battery to which cathode and anode are connected. Okay. Negative terminal of battery is connected to the dropping mercury electrode. That's why it is act as a cathode. And the positive terminal of mercury, it is connected to the battery. So it is act as a anode. Okay. And it can supply about 3 volts. Here is a potentiometer. Potentiometer can gradually apply any EMF up to 3 volts. Okay, it applies any EMF up to 3 volts to the polarographic cell by means of this sliding contact J. Okay, and the potential is vary when sliding contact is moved through this wire XY wire. Then shunt. The shunt is connected across the galvanometer, terminals of galvanometer according to the requirement. The next component is the galvanometer. Galvanometer, it is used to measure the current which is flowing through the cell. Okay, it is a polarograph. Polarograph means what? It is the apparatus which is useful for the polarographic measurements. The next point is the working of polarograph. Okay, working of polarograph. Initially, in the cell, electrolytic solution with solution of supporting electrolyte and gelatin solution is taken. Before the measurement, the dissolved oxygen is expelled out through the electrolytic solution by using nitrogen gas. Then after that, the cell is fitted with DME. Okay, and then that DME, it is act as a cathode. And here the pool of mercury or standard calomel electrode which is act as an anode. Under these conditions, we experience only the reduction of this metal ion to the solid metal at the drop of mercury takes place. Okay, the metal ions which are present in the solution, okay, they are get reduced at the drop of mercury to form solid metal. Here we consider one example. If we take a solution of cadmium chloride as a test solution, then Cd2 plus ions, okay, get reduced at mercury to form cadmium metal, and after that this cadmium metal is dissolved into the mercury to form metal amalgam. Okay, this reaction shows the formation of metal amalgam. First reduction is takes place, okay, then after that formation of metal takes place, and then that metal is dissolved into the mercury to form metal amalgam. The amalgam form is removed from the electrode and settle down at the bottom of the cell. Okay, then the height of the mercury in the reservoir is constant. Okay, it is the precaution during the polarographic measurement. The height of the DME must be constant to get a reproducible result, because if we change the height, then the size of the drop and shape of the drop changes. Okay, and due to that there are some error arises during the current measurement. So the height of the mercury in the reservoir is constant. Hence, new drop of mercury of the same size and shape grows from the capillary and giving rise to a cathode whose surface is completely reproducible. Okay, every drop of the mercury at the end of the capillary act as the cathode. Okay, and this is the most important difference between the electrolysis using solid electrode and electrolysis using DME, because when we use solid electrode, the metal ion get reduced and deposited on the electrode, and due to the deposition on electrode, the size and shape of the electrode is changes. But in polarography, the surface area of mercury drop is continuously renewed. So there is no possibility of passivity. Okay, when a usual solid electrode is used as cathode of an electrolysis cell, the deposition of the metal on it affects the shape and character of the electrode. But in DME, the cathode is reproducible or renewable. Okay, then the resulting current flowing through the cell is measured with the help of galvanometer. The current grows with the size of the drop. Okay, when the drop is coming out from the capillary tube, okay, then at that time the amount of current is increases with the growth of that drop. When drop fall down at the bottom of the cell, then current becomes zero. Okay, it is shown in this diagram. The diagram, it is a plot of current versus time. When the drop grows, okay, with the size of drop, the current value is increases. When the drop fall down at the bottom, current suddenly becomes zero, and that process is continuous. So during the measurement, average value of current is taken. Okay, it is the working of polarogram. The next important point of the chapter is the polarogram. Polarogram is apparatus, and polarogram, it is a plot of current versus voltage. Okay, and its shape is step shape or sigmoid shape. Okay, diagram shows the polarogram. It is the plot of current versus applied voltage or EMF. Its shape is sigmoid shape or step shape. There are three different portions in polarograms. Okay, first one is the AB portion, BC portion, and CD portion. AB portion shows residual current. It is due to the impurities present in the solution, as well as it is due to the supporting electrolyte. Okay, it is not due to the reduction of the, metal ion which is present in the solution. Here, the potential which is applied in between AB region, it is not sufficient to reduce the metal ions. Okay, therefore that current value is very small, and it is due to the impurities present in the solution, and also supporting electrolyte present in the solution. Okay, the next region is the BC region. Here at point B, when the potential reaches the point B, at that point a continuous electrolysis takes place. When we increase the potential after point B, there is a sudden sharp increase in the current value. Okay, therefore the region BC shows a diffusion current due to the continuous electrolysis of test cation. Okay, therefore this region shows diffusion current. The next region is the CD portion. Okay, along the CD there is no increase in current, because at point C the rate of transport of reducing cations at the surface of the electrode is equal to the rate of reduction of ions. So due to that the current is limited. Okay, therefore this portion shows the limiting current. It is the polarogram. Polarogram having three regions, AB, BC and CD. AB region shows residual current. Okay, and it is due to the impurities and supporting electrolyte. BC region shows diffusion current, and this current is due to the electrolysis of test cations which are present in the solution. And the region CD, okay, this region shows a limiting current. Okay, CD region shows what? When at higher value of voltage there is no increasing current, the current is limited. Due to what? Because at point C the rate of transport of cation to the electrode surface is equal to the rate of reduction, so that's why the current is limited. Okay, it is the polarogram and its region.